When traffic spikes and editors push rapid updates, modern content management architectures frequently fracture under the load. The friction often starts in the editor. Traditional WYSIWYG interfaces from the mid-2000s inject raw, unstructured HTML strings directly into modern React applications, creating immediate rendering bottlenecks and severe hydration mismatches. To escape these legacy editors, developers typically adopt a headless architecture. They decouple the CMS from the front end. But splitting the data layer across an external API introduces high-latency network waterfalls and forces developers to maintain duplicated schemas across two different codebases. This separation causes exponential bloat when scaling. For example, implementing multi-language routing across a decoupled system requires heavy third-party middleware to negotiate locales and execute secondary API fetches for every translated text string. Developers are forced to make a direct trade. They decouple the data repository to gain content flexibility, but sacrifice core web vitals to do it. NextBlock CMS abandons the headless model entirely. It operates as an AGPL-licensed open-source framework that integrates the front-end and the back-end into a single unified system. The entire stack, Next.js 16 server components, a Postgres database via Supabase, and Tailwind CSS, is centralized within an NX monorepo. By collapsing the front-end rendering and the database querying back into a shared environment, data requests no longer travel across external HTTP APIs. The network fetch latency drops to zero. Reunifying the stack removes the friction inherent in third-party caching scripts and API bridges. This reduction in overhead allows the core framework to maintain 100/100 Lighthouse performance metrics right out of the box. Hitting peak performance in a Next.js 16 application requires rendering dynamic content at the edge, but developers consistently hit what we call the HTML wall. Storing unstructured HTML strings forces the server to execute a CPU-intensive sanitization task before it paints the screen. To solve this, NextBlock integrates a tip-tap editor, banning raw HTML, storing content exclusively as strict node-based PostgreSQL. The content canvas is no longer a block of raw code. It operates as a fluid, self-referential tree of pure, structured data. Because the data is already structured, NextBlock maps these JSON-B nodes directly to React server components. This architecture allows developers to apply surgical edge caching across specific content blocks. Shifting from raw strings to structured JSON-B nodes permanently bypasses the sanitization tax and preserves the exact rendering speeds of static server components. Utilizing strict JSON data usually introduces a severe developer penalty. Every custom block requires hard-coding TypeScript interfaces and pushing full repository redeploys to update the site. NextBlock implements a dynamic schema engine directly into the CMS dashboard. Users can execute full CRUD operations to build, edit, and duplicate custom component layouts on the fly. Because these blocks are defined as data rather than hard-coded files, they inject dynamically at runtime. The system renders custom components instantly, bypassing Vercel redeployment pipelines entirely. This structured foundation enables Cortex AI. Cortex AI is an integrated, deterministic system orchestrator. It translates natural language specifications into direct database mutations. When Cortex AI receives a prompt, it utilizes constrained decoding. The engine physically locks the large language model inference to a strict ZOD schemac. This algorithmic constraint guarantees the AI generates valid, nested JSON-B layouts directly into the Postgres database. The model cannot output unclosed tags or corrupt the relational schema. To route these requests, Cortex AI relies on a bring-your-own-key architecture powered by OpenRouter. Instead of paying markups to a middleman platform, developers plug their direct provider API keys into their workspace settings, shifting the compute cost directly to the raw infrastructure tier. Treating the application schema as dynamic data allows artificial intelligence to step away from conversational generation, acting as a precise structural architect. Moving beyond content layouts, this unified JSON-B architecture scales natively into global commercial operations. NextBlock embeds a dual gateway monetization structure, splitting physical and digital routing. The Stripe integration governs physical goods, automating real-time tax synchronization globally. Parallel to this, Freemius handles digital orchestration, managing software licenses independent of physical logistics. To secure these transactions without adding bundle bloat, The system dynamically injects Cloudflare turnstile verifications and automatically maps privacy banner compliance for regulations like Law 25 and CASL. Integrating these native compliance checks and dual commerce capabilities proves the unified architecture absorbs deep enterprise complexity without requiring developers to piece together fragile third-party plugins. Self-hosting an open core system carries an inherent operational risk. When the upstream framework releases an update, merging those files can overwrite and destroy a developer's custom fork. To solve this versioning chaos, NextBlock engineers an automated background Git orchestration loop directly into the deployment process. The system utilizes native repository permissions to execute a daily midnight cron job, scanning the upstream source for new framework releases. When an update is detected, the loop triggers a mechanical failsafe. It executes a strict merge command with no commit and no fast-forward flags to evaluate exact code alignment before touching the live database. Background code synchronization requires this strict mechanical barrier. Without it, overlapping configurations and broken syntax would inevitably deploy to the production environment. If the strict merge logic detects a direct line code conflict between the developer's fork and the upstream core, the process halts. This halted merge instantly fires an API webhook, logging the failure state securely into the Supabase system alerts table. The next time an administrator opens the CMS dashboard, a React server component fetches that alert and renders a high-visibility warning banner. This banner deep links the developer directly to the GitHub conflict resolution interface. The live production site remains functional on the previous build while the conflict is addressed manually. To test this failsafe and evaluate the entire stack, developers can spin up the ephemeral 15-minute public sandbox. True developer experience requires eliminating the anxiety of manual deployments. By automating these safeguards, engineers can scale complex architectures without the risk of configuration regressions in production.